As we move into Module 32, what we're going to start to look at is kind of the end parts of the process. So to take you back, so far we've looked at sensory and short-term memory, which means we still have long-term left. And we looked at encoding, which means we still have storage and retrieval left as part of the processes that we talked about early on in Module 31. So in Module 32, we complete all of that. We will look at long-term memory, and we're going to look at storage and retrieval. So specifically in this video, we're going to look at the capacity of long-term memories, and then we're going to look at all the brain parts that are involved with those memories as well. So what is the capacity and location, meaning where are our long-term memories stored? Well, here's what we know. We know that the capacity is essentially unlimited. We know that it's pretty much permanent. So once something makes its way into long-term memory, it's in there forever. Now, that doesn't mean you can necessarily access it, which is retrieval, and retrieval we'll talk about later. So what about the brain parts that are involved? Well, we know that the frontal lobe and hippocampus are involved, and specifically, we know that those are the brain parts that are involved with explicit memories, meaning semantic and episodic. Now remember, we talked about semantic and episodic in previous videos. Semantic would be memories that are recorded according to meaning. So like the AP psychology content that you're learning right now. It's like a encyclopedia or Wikipedia. It's facts and general knowledge. And then episodic would be sort of like the events of your life. So a trip that you took. So let's dig more into those brain parts. What do we know specifically about the frontal lobes? Now here, we're also going to talk about the prefrontal cortex because we know that that's a specific space in the frontal lobe that's kind of set aside as a workspace. So how is the frontal lobe involved in explicit memory? Well, the whole thing is pretty much our workspace. So the rest of the brain is sending signals that might be involved in various memories because we know that those signals are all over the brain. And then the frontal lobe is responsible for making sense of them and putting them together. The hippocampus is probably more specifically known for its involvement with explicit memory because its job is essentially to connect your present, so what you're learning right now, to your past, meaning what's already in your long-term memory. So you read and took notes on this information. So you already have some knowledge. If you took adolescent psych, you have some knowledge about the brain as it relates to memory. So everything you're hearing, you're trying to connect to what you already know. Okay. You're trying to lay down this new memory. So we would say that the hippocampus works like a save button. Like if you hit save on your computer to make that transfer. All right. So it registers and it temporarily holds these explicit memories before they hopefully get moved for long-term storage. Okay. So they aren't just permanently stored in the hippocampus. That's not what happens. The hippocampus job is to transfer these memories into other parts of the brain. Okay. So short-term into long-term. So one of the things that we know is that sleep is really important for this process. So after you learn something, after you study something, being able to go to sleep and really sleep on it will help those memories become solidified because your brain continues to do work after you go to sleep. We also know that damage to the hippocampus would not affect memories that have already been stored in your brain. Okay, it would just affect your ability to lay down those new memories. So what about the other brain parts involved? Well, we also have the cerebellum and the basal ganglia. Now, I know that we haven't talked about the basal ganglia, but everything you're going to need to know about it for AP Psych is pretty much going to be in how it relates to memory. Specifically, these are the brain parts involved in implicit memories. So remember, we've talked about this previously. What are implicit memories? Those are things that are conditioned kind of over time, and then also our procedural memories. So when we talk about conditioned, remember that conditioning might be like your fear of snakes or something like that. Okay. All right. So how is the cerebellum involved? Again, the brain part more known with implicit memory. So the more likely to be tested one. We know that the cerebellum is important specifically for those classically conditioned memories. Okay. And in your book, I'm sure they talked about the handshake and tack example. So doctor greeted a patient every day with a tack in his hand, a patient that had damage actually, and to their brain, and greeted them every day with a tack in their hand. And it obviously that would hurt, right? If you shook hands and there was a tack in your hand. And eventually that patient refused to shake hands. So what did we know? Well, from that, we can definitely tell that the cerebellum can still, regardless of brain damage, transfer those classically conditioned memories in. Okay. And then the basal ganglia is specifically involved for that motor movement type of stuff. So anything tied to procedural memories or skills, like riding a bike or drinking from a cup or learning dance moves or whatever else it might be. So it specifically coordinates that. Now, yes, we've already talked about the cerebellum. We know the cerebellum's involved with that. But now we're going to break it down even further for the memory component of this. Okay. We know that the basal ganglia receives input from the motor cortex for how to specifically coordinate the movement, but it doesn't return the message. So that's why we aren't consciously aware of how we learn these things. We just kind of do them. All right. So what would we see if there was damage, right? What would happen if one of these memory systems was damaged? And so what we're going to do is watch a very short clip, I think it's about 3 minutes, of one of 2 case studies that you should associate with memory damage. This is Clive Waring, and then the other one is HM, but we're going to talk about HM in our next module.
One man is consigned to live entirely within the present, with terrible consequences. Clive Waring has the worst case of amnesia ever known. 20 years ago, he lost his memory, and now his wife, Deborah, is the only person he recognizes.
Clive really only has less than 30 seconds memory. And sometimes it's as little as perhaps 7 seconds. It's as little as a sentence. I'm going to see your sister, Adele. Her daughter's got married recently in New Zealand. And so they're having a party.
Funny how the ladies acquire a different title when they get married.
Do you know who I'm going to see tomorrow?
Buckingham Palace.
No, really guess.
I don't know.
You don't know? Adele.
Oh, I see.
Do you know why I'm going?
No.
She's having a party at her house tomorrow.
It's her birthday, isn't it?
No.
Yeah.
Do you know why?
No.
It's to do with her daughter.
I see.
Do you know why her daughter's having a party?
No.
Guess.
No, I don't.
She's just got married.
Oh, I see.
She just got married in, do you know what country she just got married in?
No, I don't.
In New Zealand.
Oh, I see.
Yeah. The sentence he is in, he will probably have forgotten the sentence before. You ask him a question and he'll give you an answer. But while he's giving you the answer, he's already forgotten the question. That's how short it is. I'm going to see your kids tomorrow.
You see my kids?
Yeah, your children.
What are they up to now?
Do you know what they're up to now?
No.
Guess what you think they're up to.
No idea. I couldn't guess. I don't know what their O-levels were. They hadn't got an O-level last time I was conscious. So I didn't know what possible thing they could do, did I?
No.
No, I couldn't possibly guess.
Where do you think they are?
No idea. I don't know where I am.
Yep. All he has is void behind him.
It's been like death. I've never seen a human being before. Never had a dream or a thought. The brain has been totally inactive. Day and night the same. No thoughts at all. As far as I'm concerned, the doctors have been totally incompetent. I've never seen a doctor the whole time. Oh, look, she's come.
All right. So what's kind of interesting about Clive Waring is that he's actually like a famous composer and pianist. So he can still play beautiful, beautiful music. Like he can sit down at a piano and play beautiful music, but he has no idea that he can actually do that until he sits down and somebody forces him to start playing. Additionally, he greets his wife like that, no matter if she left the room to go grab a drink of water or she hasn't seen him in 2 weeks. Okay. So he just has this immense amount of love for his wife. And he just constantly, it's like brand new every time she shows up. He also keeps a journal. And in that journal, it says, I mean, it's just pages and pages, you guys, of him saying, It's 10:36 a.m. I have finally awoken for the very first time. And then it'll say like 10:38 a.m. I am finally awake and conscious. So it's really interesting to think about. Now, where is his damage, right? What part of the brain is damaged? And why is he able to do or remember some of the things that he's able to do or remember, right? So thinking through that, what are those brain parts? Our final piece that we're going to look at is how do emotions affect memory processing? And then we're going to put this all together. So I'm going to ask you to come back to Clive and try to figure out why he can do what he does or remember what he remembers. So in terms of emotions and memory processing, on kind of a neural level, we know that emotions increase our stress hormones. And when our stress hormones are increased, it activates our memory forming areas. So more specifically, we know that strong emotions lead to stronger memories. So those stress hormones that I talked about, they increase glucose, and glucose triggers the amygdala. So the amygdala is obviously involved with memory formation that's tied to emotion. We know that arousal can kind of like sear important events into our memory, meaning it can like make things pretty crystal clear, and that's more specifically flashbulb memories. But we also know that while arousal can kind of make important events seared into our memory, we know that if something is kind of irrelevant, that level of arousal can also disrupt our memory for things that are sort of irrelevant or don't really matter. We know that there are drugs that can block stress hormones. And when we can block those stress hormones, it actually does interrupt people's ability to remember things that are upsetting. So that's kind of a cool area of research when you think about like all the traumatic and terrible things that could happen. So kind of like I was talking about before with searing important memories into our or important events into our memory, that would be flashbulb memories. What we know is that the stronger the emotional experience, the more reliable the memory. They are vivid and dramatic, and we also rehearse them more in our brains, which kind of lays them down. Okay, so a flashbulb memory is something that is so big, right? Like a lot of people talk about 9/11 and the Twin Towers, but for you guys, like you weren't here, you don't remember that. But that's still what like textbook authors might use. Okay, so like assassinations or things like that. For you, it could be like a car accident, or maybe like the day you found out your parents were getting divorced, or whatever, anything that's like terrible, or anything that's super positive, right? Like a parent getting remarried, or I don't know, the birth of like your niece or nephew, right? Those could be flashbulb memories depending on the type of emotion that you have associated with that. Okay. An additional thing to be aware of just for our overall mental health is that when we look at stress enhanced remembering, so meaning like ongoing high level stress that's being released, we know that prolonged stress can actually start to destroy our neural connections, and it can actually shrink our hippocampus. Remember, the hippocampus is the area that ties kind of our current, so our present, to our past. Okay, it makes it so that we're not living in one specific moment. So when we talk about ongoing trauma, it can actually do damage to your brain areas tied to memory. So would you be able to piece this all together? Right? So we've seen this diagram before. I've included the parts of the brain that are tied to memory. And then would you know what type of memory they're tied to? So while I'm talking, you should be thinking through that. And additionally, how might understanding this diagram help explain Clive Wearing? Right? So when we are in class, that's one of the things that we'll talk about. We'll talk about Clive, what parts of his brain were destroyed, why could he do the things that he could do, and why couldn't he do or remember the things that he couldn't. So moving on to the answers. These are the answers. So being able to label, but also understanding the function. You guys, as we try to put this all together and kind of tie back memory processing, we already looked at sensory and short-term memory, right? We move very quickly past long-term because what we really have to know about it is really just that it has an unlimited capacity and it's an essentially permanent storehouse. So how do those memories get in? So a reminder that we look at the automatic processing and the effortful. Automatic processing would be implicit memories. And then we know that that's the cerebellum and the basal ganglia. And then we also kind of break that down into what that means. And then effortful processing, which would be explicit memories, hippocampus and frontal lobe. And again, we break that down into semantic and episodic. So just a way to kind of put that all together. Our next video is going to look at the neural storage of memories. So where do those actually exist? And then it's also going to look at retrieval. So the final step in our process. How do we get information out of our long-term memory once it's in there?